Hello children, since exams are on the way, we're gonna do the past paper, that is 9702 is physics of October November paper 2, and this is second variant of October November series 2025. Let us do the question, let us revise the question paper, since we know that these will going to play important role in your upcoming examination. Let us do it one by one, and I to explain each and everything to my level best. Okay, let's start the session. Here is the first question. And the first question, it is about scientists are investigating the variation in air pressure at different location on a mountain. The scientists take measurements of several physical quantities at each location. We need to complete the table, that is 1.1. We need to put a tick mark so that which belong to a scalar and a vector quantity. We need to write the SI base unit also. First one, which they had given us air pressure. We know that air pressure and the temperature. First one is temperature. We know the temperature, the SI unit of temperature, the base unit is Kelvin. So it is Kelvin. We know that it is a scalar quantity. The second thing is air pressure, and air pressure, we know the formula for air pressure. I think so. The pressure, which is equal to force divided by area, and the base unit for the force is kilogram meter second to the power minus 2 divided by the meter square. So if we cancel it out, we will get kilogram meter inverse second to the power minus 2, and this is going to be a base unit, kilogram meter inverse second to the power minus 2. This is also a scalar quantity, but we are having force here. Why this becomes a scalar quantity? We know that although force acting on an area, air pressure, it is representing only the magnitude of the normal force per unit area. And at a specific point, we know that because it will act equally in all direction rather than having a single defined direction. So that air pressure is also a scalar quantity. Let's go for the next question. At one location, the density of the air is 1.1 kilogram meter to the power minus 3. So the density rho is given here, 1.1 kilogram meter to the power minus 3, and then a spherical weather balloon is filled with a gas and released from rest. The balloon has the radius of 0.90 meter. Okay, radius is also given of the balloon, 0.90 meter. We need to calculate the up thrust. So we know that the up thrust formula, up thrust, which is equal to the density as well as the acceleration due to gravity as well as the volume of the sphere, since it is a spherical weather balloon. We know the density, which is 1.1, into the acceleration due to gravity, which is 9.81 times the volume. The volume of sphere, we know that it is 4 by 3 pi r cube. So 4 by 3 pi and 0.9 the whole cube. And this comes out to be the calculator, and we are left with 33 Newton. That's the thing. Going for the next question, explain why an upthrust acts on the balloon. Why an upthrust is acting on the balloon? Why it is acting? We know that if a balloon is there, due to the difference in height, due to the variation of the pressure at two different regions, at the topmost and the bottommost point of the balloon, due to the variation in the height, an upthrust will act actually. So you can write the question, the upthrust acts due to the difference in pressure between the top and bottom surfaces. We also know that the pressure in the bottom surface is greater compared to the top surface. So the pressure in the bottom surface is greater than the top surface, or compared to the top surface of the balloon. So we can also say that the bottom surface experiences a larger force. So this is the answer for the subdivision 2. Question number 1, B2. The third one. So they had given the balloon has weight 19 Newton. Okay. So a free body diagram. This is the balloon and it is about the weight. So the downward force weight which is given as 19 Newton, and we had calculated the upthrust also, it is 33 Newton. So the upthrust which will be 33 Newton. Calculate the magnitude of the initial acceleration of the balloon. So for calculating the initial acceleration of the balloon, we need to find the resultant force. So the resultant force will be equal to 33 Newton minus 19 Newton, which will give us 14 Newton is the resultant force. And we know the formula for the force. So force resultant, which is equal to 14 Newton, mass into acceleration, which will be equal to 14 Newton. So if mass and acceleration is equal to 14 Newton, we know that the mass. So we know that the mass of the balloon, which is equal to the weight, because weight is equal to mass into gravity. So we can write this 19 divided by 9.81 times the acceleration, which is equal to 14. Okay, so the acceleration will be 14 times 9.81 divided by 19. So while calculating, you're getting the answer, that is 7.2 meter. The unit is given here. So the answer will be 7.2. So this is the answer. Going for the next thing, a quantity C is related to the motion of the balloon is calculated from three measured quantities K, F and V using the formula C is equal to 2KF by V square. We need to calculate the percentage uncertainty. Actually, the percent uncertainty are given. We need to determine the absolute uncertainty in C. So what is the absolute uncertainty? So we are having the formula C is equal to 2KF divided by V square. This is the given formula. So for finding the percentage uncertainty by applying the rules, percentage uncertainty of C is nothing but the constant 2. Let us leave the constant. Percentage uncertainty of K plus the percentage uncertainty of F plus, since we are having the square, the percentage uncertainty times the square, it is V. First, let us do with this. They had given all the three things, the percentage uncertainty value. So percentage uncertainty of C, which is equal to 5 plus 3 plus 2 times 4, which will be equal to 16%. But we need to find the absolute uncertainty. So for finding the absolute uncertainty value, we know the percentage uncertainty formula, percentage uncertainty, which is equal to del C divided by the value of the C. This is the actual value and this is the absolute uncertainty value. So rearranging the formula, absolute uncertainty, which is equal to, and it is times 100. It's very important because it is percent uncertainty. So absolute uncertainty is equal to percentage uncertainty times the actual value of C divided by 100, which will become 16 times 1.8 divided by 100. So while calculating, you'll get the value 0.3. So the answer is 0.3 for this question. Going for the next question. Okay, so this is the second question, which is carrying nearly 12 marks in total. So total 12 marks, and it's about a spacecraft in deep spaces uses jets of hot gases from its thrusters to change its velocity. This is the figure Okay, they had given a figure and they had given three thrusters. Thruster A is here, thruster B is here, and thruster C is towards the left side, on the right hand side. Thruster A and B, it is going to carry or lift the aircraft, spacecraft in the upper direction. Thruster C is going to move the spacecraft towards the leftward direction. Okay, let us get into the question. They had given thruster A is a distance of 1.6 meter leftward from the center of gravity of the spacecraft. They had given the center of gravity. This is the center of gravity. Thruster C is a distance of 0.4 meter. Okay, this is at a distance of 0.4 meter. This is at a distance of thruster A is a distance of 1.6 meter from the center of gravity. Okay, so which they are explaining here. Thruster A is activated, producing a force of 60 Newton upwards. So this is going to give a force of 60 Newton in upward direction. Thruster C is also activated, and this is going to give a force of 220 Newton in the leftward direction. So we need to calculate the resultant moment. Okay, for calculating the resultant moment, now, this resultant moment calculation, the center of gravity, COG, this is going to act like a fulcrum or a pivot. So, since it is going to act like a fulcrum, we know that if the aircraft is going in this direction, let us consider this is going to give us a clockwise rotation. If the thruster C is activated, this is going to give us an anti-clockwise rotation on the aircraft. Okay, so we know that the force acting because of the thruster A is 60 Newton. So we know the formula for the clockwise direction or the clockwise motion. That is force into the distance between the fulcrum or the center of gravity and the thruster A. We know that the force is given as 60 Newton and the distance is given as 1.6. Okay, so in the clockwise moment, it is going to give the clockwise moment provided by the thruster A is 96 Newton meter. And with respect to thruster C, this is going to provide a force of 220 Newton. If 220 Newton is completely provided by the thruster C, and if the distance is larger, we know that the aircraft will be going completely in the leftward direction. Okay, it's just a practical application while you're thinking, but it's not going to that so because we know that this is going to act in this direction. So the distance between the center of gravity and the thruster is nothing but it is 0.4 meter. So while calculating for the anti-clockwise moment, that is force times the distance, which will be 220 times 0.4, and this is going to provide us 88 Newton meter. And what will be the resultant moment? We know that 96 minus 88, which will be 8 Newton meter is the resultant force. Okay. So the next question. Next question is nothing but state and explain whether the forces from A and C are coupled. Okay. So recalling about a couple, when the two forces are equal, we can say that it is a couple. But here we can say that this 90, I'm sorry, the 60 Newton and the 220 Newton forces, they are not actually same. So since these two forces, we need to explain that since the two forces are not equal and hence they are not a couple. Okay, going for the next explanation. Thrusters A and C are now switched off. Thinking about the question, we know that now the spacecraft is stationary, so U will be 0. Since A and B are switched off, Okay, so what happens to the velocity? It will be zero because the spacecraft is stationary. Now only thruster B is activated at a time t1, producing a constant force on the space of the Earth until the fuel runs out. Since the fuel is also running out, the mass is going to decrease because the fuel is also decreasing, and we need to sketch a graph. Okay, kindly remember the formula, recall the formula, the force which is equal to mass times the acceleration. So if you're having the acceleration this side, bringing the mass here, F by M, and they told us force is now stationary. So I can also write that 1 by M is directly proportional to A, or the acceleration is inversely proportional to the mass. Since m mass and acceleration are inversely proportional, if the acceleration increase or if the mass decreases, acceleration will increase. The mass increases, acceleration will decrease. Okay, so what is happening here? They had given us the speed and the time graph. We know that the gradient of the speed time graph will give us what? Acceleration. Okay, so if the gradient increases, the acceleration will increase. Since the mass is decreasing, the acceleration will increase. So acceleration is going to increase, so the gradient is also going to increase. So what can we do? Shall we draw a line like this? Since the acceleration is increasing, or do we need to draw like a curve? So we have been provided with the gradient is increasing, so we need to go for the curve actually, because the gradient is going to increase. So the slope is going to increase, so we need to draw a graph like a curve. Going for the next question. The spacecraft now splits apart into a carrier and a payload as shown in the figure. During the split, an average force of 5,500 Newton acts on the payload for the time 0.36 second. The velocity of the payload increases by 8.5 meter per second in the upward direction. Okay. We need to state the principle of conservation of momentum. So what is the principle of conservation of momentum? Here they had given that the force acting on the payload, which will be 5,500 Newton, and the time period is also given, which is 0.36 second. Done. Okay. Now they are asking us to state the principle of conservation of momentum. We know that's very simple question, and the principle of conservation of momentum states that the total momentum of the system, it will be constant, remains constant if no external force acts on the system. So this is the principle of conservation of momentum. Show that the mass of the payload is 230 kilogram. Let us get into the diagram. So they're asking us to state the mass of the payload. Okay, we are provided with the force acting on the payload in upward direction and also the time. So we need to find the mass. Recalling the formula, we know that the force is nothing but the rate of change of momentum, change in momentum by change in time. They had given the time, also they had given us the force. So 5,500, which is equal to change in momentum divided by the time period, which is given as 0.36. So the change in momentum, which is equal to 5500 times 0.36, thus the change in momentum will become 1980. This is the change in momentum. Okay. So this is the change in the momentum of the payload actually. We know that momentum formula, that is nothing but the mass of the payload times the change in velocity, which is equal to 1980. And we don't know about the mass actually. So the mass of the payload times the velocity which they had provided is 8.5, which is equal to 1980. So coming for the mass of the payload, which is equal to 1980 divided by 8.5, which gives us 232.9 kg. I'm going to round off this to two significant figure. If you are rounding it off, you will get the answer 230 kilogram. It is nothing but the mass of the payload. Okay, going for the third question. Calculate the magnitude of the change in velocity of the carrier. Change in velocity of the carrier and the change in velocity of the payload. And also they stated, as we know that the force acting on the payload is 5,500 Newton, and the momentum acting on the payload in upward direction is 1980 kilogram meter per second. And we know that there is no external force acting on it. The spacecraft is not accelerating. So definitely, according to the principle of conservation of momentum, the conservation of momentum state that the initial momentum will be always equal to the final momentum. So if you're subtracting these two, this will become zero. Then definitely, if the payload change in momentum in upward direction is 1980 kilogram meter per second, then definitely the same momentum is going to act downwards. This is also going to be 1980 kilogram meter per second. So change in momentum of the carrier, which is equal to 1980. So change in momentum, the formula, that is mass of the carrier times the change in velocity of the carrier, which will be equal to 1980. They had provided us the total mass, the combined mass of the payload, which is equal to 2.5 into 10 power 3 kilogram. So it is 2500 kilogram. And we had also find out the mass of the payload actually. The mass of the payload is, they had given it already, it is 230 kilogram. So for finding the mass of the payload, for finding the mass of the carrier, we need to subtract the total mass and the mass of the payload. So if you're subtracting it, it is now 2500 minus 230 kilogram. Okay, it is 230, which we will get 2270 kilo. So applying the mass here, 2270, and change in the velocity of the carrier, which is equal to 1980. So the change in the velocity, which is equal to 1980 divided by 2270, change in velocity becomes 0.87 meter per second. So the answer is 0.87. Going for the next question. A spring is fixed at one end and attached to the frame of the pulley at the other end. Definitely using the spring constant. So we need to go into the Hooke's formula. What they're telling is that a spring is being attached to a pulley, and we are having two ropes which is attached to the pulley. The spring is stretched to a fixed length using the cable, and this figure is showing that the spring obeys the Hooke's law with the spring constant, which is K value is given, spring constant. A force F acts on the spring, tension P acts on the cable, the pulley is in equilibrium. since they had given that the pulley is in equilibrium, we need to get into the two concept, that is the force acting in this direction will be equal to the force acting in this direction. So we need to draw the force because of the spring. Definitely the force will be acting in this direction. Because of the two ropes, a tension force will be acting in each of the ropes, so T and T. So from the given statement, which is they are in equilibrium, and they had given the force F is actually 110 Newton. Here the force is 110 Newton, and the tension force we need to find actually. So the force in the left hand side will be equal to the force in the right hand side. Force in the left hand side, we know that it is 110 Newton, which is equal to the 2 times the tension force. So 110, which is equal to 2T, and T comes to be 110 divided by 2, which is 55 Newton. It's the tension force acting on the spring. We need to calculate the extension. For calculating the extension of the spring, we know the formula, the Hooke's law, which is F, which will be equal to Kx or E, I can write, that is extension. They had given the spring constant value is 250, and force we know that it is 110 times the extension. So extension comes to be 110 divided by 250, which will be equal to x. So the extension will be 0.44 meter. Okay. Then the question, a second identical spring with the same spring constant. We are going to add another spring actually. So two springs are being added. Okay, the tension in the cable is kept the same. Okay, the tension is going to be the same. The pulley is again in equilibrium. So the pulley is again in equilibrium. Now we need to determine the tension, the spring constant. Okay, so we know that since these are in the equilibrium, force in the left hand side, which is equal to force on the right hand side. So we know that the spring, the force exerted by the tension force, which is 55 Newton, I think so. Yes. So here we are having 55 Newton. Here we are having 55 Newton. And we don't know the force. So force F is going to act. So we can write for finding the extension, we know that the force plus force on the spring, which is equal to 55 plus 55, 2 times the force, which will be equal to 110. So the force will be 55 Newton. We need to determine the extension of the spring now. Okay. So we know that F is equal to K times the extension spring constant. We know that 55, which is equal to, it's not going to change, to 50 times the extension E. So 55 divided by 250, which is equal to extension, and the value comes to be 0.22 meters. 0.22 meters the extension. Now going for the second question, we need to find the ratio of the elastic potential energy stored in the spring. So for finding the elastic potential energy, we know the formula. The basic formula for the elastic potential energy in case of a spring, that is nothing but half K extension square. And the first diagram in 3.1, we know that there is only one spring connected, and in the diagram 2, 3.3, two springs are connected. So we need to calculate the ratio. For calculating the ratio, let us have the extension which is having only one spring, extension 2, which is having 2 times half kx square. So we need to find the ratio E1 divided by E2, which will be equal to half, k value is 250, into the extension for the first spring 0.44 the whole square, divided by 2 times half into 250 into 0.22 the whole square. So we can cancel this, cancel this. We're having 0.44 square divided by 0.22 square, which will be 44 into 44 divided by 22 into 22, and else we are having 1 by 2 here. So this and this get cancelled, this and this get cancelled, 2 times 2 times. If you are cancelling this, the ratio will be 2:1. So this is nothing but general revision. We know the formula already. Kindly get into this question. Kindly spend 15 to 20 minutes for looking at all the question. Let us meet in the session, offline session. Let us revise all other question in the same question paper tomorrow. Thank you.